Okay, so this is basically what we've been doing. Hopefully it's not too difficult at this point. It is, that's too bad. Okay, so we're gonna be taking a look at calcium's MCI. So for MCI's most common ions, we just go to the periodic table. We find the element, we got calcium right here, and we just look at what column it's in. So what is calcium's MCI? Yeah, +2, right? So we just got it right. Calcium is +2. And then it's going to be reacting with hydroxide, which is a polyatomic. So if we go right here, we look for hydroxide. Hydroxide is right here. It's basically me, OH negative. And so it's going to be OH minus, which is perfect because I'm a little bit negative. Okay. All right. So between the two of these, how many hydroxides do we need to balance it out? 2. Okay. So we just put a 2 right there. And then just because I'm still seeing some people mess up, like the left side is completely correct, but they mess up the right side for some reason. I'm going to recommend just write the 2 polyatomics right next to each other like this. And then since you need 2 of the polyatomic, you just put parentheses around it and put a 2. Okay, so that's kind of I think the easiest way to do it. Just write the cation, anion next to each other. And if you need more of one of them, you can just put the number right behind it, and then polyatomic at the parentheses. Okay, and that's pretty much it. Oh, and then the name. For the naming, the cation is calcium, so we're just gonna write calcium, and then hydroxide is the anion, and since it's a polyatomic, we don't need to change the ending. So calcium hydroxide. Okay, and that's pretty much it. Any questions on that? All right, so today we are going to be, again, adding more things onto this. But yeah, all we're going to be needing is that table that's in front of you. And I'm going to teach you guys how to read that today, and that's pretty much going to be it. After that, we will be combining this with stoichiometry and stuff like that in about a week or 2. So something to look forward to. Okay, so let's get into it. So today we're going to be learning solubility rules. So let's talk about what solubility is so we can learn the rules for it. So I will tell you guys what you guys need to write down, what you don't need to. So don't write everything down. So solubility, do not write this down. Basically, it tells you if a chemical can dissolve in something. Okay, usually we're going to be talking about water in this class. Okay, now these 2 things I do want you guys to write down. Basically, if a chemical is soluble, it means it can dissolve. Okay, so it can dissolve in some type of substance. Again, we're going to be talking about water. Okay, and if it is insoluble, it cannot dissolve. And that's pretty much it. Okay, so we're going to be learning about which chemicals can dissolve in water, which ones cannot dissolve in water. And that's what that table that I passed out earlier is going to be for. Okay. So if a chemical is soluble, it can dissolve in water. If it is insoluble, it cannot dissolve in water. All right, and so if a chemical is insoluble, it forms something called a precipitate, okay? And a precipitate is a solid that forms in a liquid, okay? So later on, I think it's next week, we're going to be doing our lab for this unit. And you're basically going to be mixing 2 clear liquids, and you got to predict whether a precipitate or not forms. And a precipitate basically is a solid that forms in a liquid. Okay, you could just write this part down right here. Okay, and so it depends on how much precipitate is formed, but it could look like some kind of cloudiness in your liquid. You could see gunks or chunks, or the color might change dramatically. That's what a precipitate is. And that's pretty much it for the vocab. We're going to jump right into practice problems after this. So make sure you guys have that handout handy. And so let's actually get started with a couple practice just to see if we, just so that we can get comfortable using the solubility table, okay? So we're going to be taking a look at these 2 chemicals right here. If it's hard to see, actually I'll do this and I'll pull up the thing. So let's start with this compound right here, ZnCl2. Okay, now, when we got a chemical's formula, it's actually really easy to figure out if this thing is going to dissolve in water or not, okay? All we got to do is figure out what the cation and the anion is that makes it up. So ZnCl2, remember the first one is positive, so it's going to be Zn. And then the second one is going to be our anion. And I know there's two of them, but that's just going to tell us what the charge is. Cl is -1 each, and we use that to find Zn, which is going to be 2 plus. Okay, so ZnCl2 is made out of Zn2 plus and Cl minus. Kind of what we did last time where we reverse engineered the formula. And that's what we'll kind of be doing today. Okay, does this part make sense? How we got these ions? Okay. All right, so once we get our ions, we can use our table to figure out whether this is going to be soluble in water or not. So let's take a look at our little half sheet that you guys should have. Okay, and what we're going to do is we're just going to line up the two ions that we have. So we have Zn. The positive ones are all on the top, so we got Zn. And we just need to cross it with Cl. And it says SOL, which is soluble, which means ZnCl2 is going to dissolve in water. And that's pretty much it. So Zn's right here. Cl is right here. You just line them up. And that should tell you that it's soluble. And so ZnCl2 is going to be soluble. And we're all good. And you can just write SOL. That's it. Pretty easy, right? Okay, so I'm going to give you guys about, let's say, 5 minutes. I want you guys to try numbers 2, 3, and 4 on your own. 4, you'll have to figure out the formula, but it doesn't tell you to find the formula. So if you could do it without finding the formula, then go ahead and try it out. So I'll give you guys about 5 minutes to try 2, 3, and 4. We'll double check our answers, make sure we're all on the same page, and then we'll move on to the next one, which is what you'll be seeing on your assignment, okay? Okay, so let's start with this compound right here. I'm just gonna speed through it, just give you guys the charges. But you guys should have identified that this is gonna be Fe3 plus. And we know that because we got 3 nitrates, which are NO3 minus. Okay. So there's 3 nitrates, every one of them is minus, so Fe has to be 3 plus to cancel that out. Okay, so we go to our solubility table. We're just going to line up Fe and nitrate. So we got Fe right here, and we're going to go down till it hits nitrate. And then you should see that it is soluble. So this guy is also going to be soluble. Super easy. All right, let's go on to the next one. So the anion right here is CO3. And if you look on your table, it's 2 minus. And it is balanced out by 2 Ags, which means it'll be Ag plus. Okay. So you got Ag plus and CO3 2 minus. And the way that we figure out Ag is we just need to balance out the carbonate. Okay, so we go look for Ag and CO3 on our table. So Ag is right here. We line it up with CO3, and it looks like this one is insoluble. So this guy will not dissolve in water. So we can just write insol. All right, and then last but not least, we got lead 2 phosphate. Now, this one's actually a lot easier because if we look up lead, it's Pb. And we don't even need to cancel anything out. It tells us that it's 2, so that means it's lead 2 plus. And then we got phosphate, which is always going to be PO4 3 minus. Okay, and we get that from our polyatomic chart. So same thing again. We look up Pb and PO4. We line them up. Oops, wrong table. Oops, wrong table. Pb and then phosphate is going to be insoluble. It's right here on the very far right. Okay, that's going to be insoluble. So if you guys got all those correct, good job. You guys should be in really good shape for today. Okay. Okay, any questions on any of these? Yeah. If you can figure it out without doing it, you can just write SOL. Yeah, because some of you guys, eventually you'll get it. You guys, most of you guys will be good enough to just identify it, and you can just line it up, and you should be good. Yeah. Only give me the formulas and stuff if I ask you for it. Oops. Okay, let's go on to the last type problem, and this is what you'll see on your assignment. Now, this looks a lot more intimidating than it actually is. So I'm gonna go over how to do it with you guys, and then yeah, I'll let you guys get started on your assignment. Okay, so it's kind of boring just having one compound and seeing if it dissolves in water. And what you'll be doing in your labs and stuff going forward is you're gonna be mixing two chemicals together, and you're gonna be figuring out if mixing them causes them to react and make a precipitate. Okay, and so if let's take a look at this formula, and I'll show you guys how to do this problem. Okay, it's not as bad as it looks. Okay, so we have a chemical equation right here, and you guys see these parentheses, right? Okay, so I want you guys to jot this down before we start the problem. So there are some things that we can put in these parentheses. Okay, so if you ever have a parentheses with an S inside, it means that it is a solid. So basically it's a precipitate. So this chemical is a solid. Okay, the other variation we can have is we can put AQ. Okay, AQ means that it is aqueous. Aqueous just means that it is soluble in water. Okay, so those are the two things that we can put inside of our chemical equation. And this is kind of our way of just telling the person who's looking at the equation whether or not this chemical dissolves in water or this chemical produces a solid in water. Okay, and that's what we'll be figuring out with these problems. Okay, and from here, it's basically the same thing that we've been doing. Okay, so some of you guys are probably looking at this and being like, okay, I could already figure out what's going to go in there. So I'll do one of them with you, and then I'll have you guys finish up part A on your own, and then we'll move, and then I'll go over how to do B and C, okay? All right, so the first one's super easy. We got K and OH. You guys should be able to identify that this is going to be K plus and OH minus. So we line them up, and it is soluble. And so since it is soluble, we're just going to write AQ inside of the parentheses, okay? Yes. It means aqueous. It means it dissolves in water. Yeah, it's just a fancy way of saying that. Okay, AQ. All right, so I'm going to give you guys about 2 minutes. See if you guys can finish up the other three, and then put in whether it is a solid or aqueous. And then after that, I'll go over how to do B and C, and then I'll get you guys started on your side. Okay, so take about 2 minutes to do that. Cool. So MgBr2 is going to be soluble. So we're going to write AQ for our parentheses right here. Okay. Okay, and so that is going to combine with KOH. So we did the reactant side. They're going to react together and make these two compounds. So let's start with KBr. So KBr is composed of K plus and Br minus, which is also soluble. So we can write AQ right here. Okay, and then lastly, we have MgOH2. You should be able to tell that it's magnesium and hydroxide. And this one is insoluble. So this one does not dissolve in water, so it forms a solid inside of water. So basically, we're mixing two chemicals that dissolve in water. So they're like two clear chemicals. You mix them together, and all of a sudden, you're going to start forming a solid inside of your solution. Okay, so that's why we identified, just to show that mixing these two can form solids. Okay. All right, so I'm going to show you guys how to draw the picture of the system, and then we'll be all done. Okay, so on your paper, you can just draw like a small box. You're going to be writing inside the box, so make it like somewhat of a decent size, maybe like 3 or 4 rows. But we're going to draw a container, and inside of the container, we're going to be looking at the reactant side, so the left side of the equation and the right side of the equation right here. Okay, so inside of this container, we're going to be putting KOH, and KOH, since it dissolves in water, it's actually going to turn into the ions that make it up. So it's going to turn to K plus, and it's going to turn into OH minus. Okay, so that's how we draw the picture. So first we put in KOH. Okay, and KOH, since it dissolves in water, it's going to dissolve into the ions that make it up, K plus and OH minus. Next, we're going to put in this compound right here. And since this guy also dissolves in water, it's going to turn into the ions that make it up. It's going to turn into Mg2 plus, and it's going to turn into Br minus. Now, I know there's two of them, but you guys can just put Br minus, and you're totally good with that. Just identify which ion it is. You don't need to tell me how many there are. Okay. Make sense? So far, so good? Okay, last one. We're going to do this right side container, which is going to be the product side. And so if we put in KBr, since it dissolves in water, we're going to write that it dissolves into K plus and Br minus. Okay. And since that we break it up because it dissolves in water. But if we take a look at MgOH2, this guy does not dissolve in water, right? And so what we're going to do is we're going to create like this little mound on the bottom, and we're going to keep it MgOH2. Okay, because it's a solid, it doesn't dissolve in water, it just stays as a precipitate. And then for part C, identify the precipitates. We can just say that this is the precipitate. MgOH2 is the precipitate. Okay, and that we'll cut it right there. That's basically what you'll be doing on your assignment, just figuring out if it's aqueous, solid, and then drawing a picture of the system, just so we can get a visual idea of what it looks like, so that we're ready when we do our lab next week. Okay. All right, any questions? All right, you guys can get started on your assignment. Let me know if you guys got any questions or if you guys want to check your answers.